Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you've got everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. If DataOps sounds like the perfect antidote to your pipeline woes, Data Kitchen is here to help. Data Kitchen's DataOps platform automates and coordinates all the people, tools, and environments in your entire data analytics organization. Everything from orchestration, testing, and monitoring to development and deployment. In no time, you'll reclaim control of your data pipelines so you can start delivering business value instantly without errors. Go to dataengineeringpodcast.com/datakitchen today to learn more and thank them for supporting the show. Your host is Tobias Macey, and today I'm welcoming back Chris Bergh from Data Kitchen to talk about ways that DataOps principles can help to reduce organizational complexity. So, Chris, can you start by introducing yourself?
Hi, my name is Chris Bergh. I'm CEO and head chef of a company called Data Kitchen in Cambridge, Massachusetts. And we focus on a new area in data engineering and data science that we call DataOps. And so we have a software product and have been trying to evangelize the concept now for 5 or 6 years.
And do you remember how you first got involved in the area of data management?
Well, Tobias, I've been sort of involved in technology for almost 30 years. And the first 15 years of my life were more sort of software and algorithms. So I worked at NASA Ames on a project to automate air traffic control. I worked in enterprise software and actually one of the first business, consumer websites that did recommendations and social chat. And then about 2005, I sort of left the world of sort of writing code and managing people who wrote code, and then jumped into the world of, what we now call data engineering or data science or data analytics. And I worked for a company that did kind of healthcare analytics, and I was the chief operating officer of that company. And so I had people who did what we call now data engineering working for me, people who did BI or data analytics, people who did data science, and those were all, we used different words for them 10 or 15 years ago. And, my life was just trying to make the trains run on time. And I sort of lived this life of kind of it's somewhat the trio of pain of people who deal with data and analytics. And, the first pain comes from your data providers who sort of don't care about you and give you crappy data, and you've got to deal with that. And then the second pain really comes from, the customers of analytics. And, you can't sort of build them a house and walk away. They sort of constantly have a river of questions that you've got to answer. And then, the third pain is kind of sort of a subject of this talk, is that the people who your teams have to relate to, whether it's sort of production or other teams in the organization, is complicated. And even just working with your teams on having them relate to each other and coordinate. So there's this organizational complexity that creates these kind of trio of pains. And then my co-founders and I, we all sort of have similar sort of software and data and analytics hybrid backgrounds, both kind of very very technical. I've written a lot of code and also have managed people. We started this company, Data Kitchen, about 6 years ago when we, I guess, realized that set of pain that we had lived in our sort of analytic company that called Leapfrog RX was a generalizable problem to people who are doing data and analytics in general. And so we've been on a mission, and we called that the solution to that pain DataOps. And so we've been working in this sort of process, or talking about the concept of DataOps, and we have a software product that does that, and have built a company devoted to that mission.
And so in the space of the data responsibilities within an organization, depending on the size of the group and the specific tasks that they're trying to perform, you listed a number of different responsibilities in terms of data engineers, data analysts, BI engineers, data scientists, and in some organizations it might get broken down even more into things like the person responsible for data governance. And I'm wondering what you see as being some of the typical ways that those data and analytic teams are organized and some of the specifics of the roles and the structure there.
I wish it was a typical way. There's a lot of varied ways. And there's even, it goes down to the naming, right? Because, data engineers, they used to be called, sometimes they were called DBAs. I used to call them ETL engineers. Some people call them data plumbers and data cleaning. And I think one of the great improvements in the last 5 years is the elevation of the data engineering as a full-fledged profession. And I think that's fantastic. And then, and their job is mainly to take data and put it in a place in a meaningful format for others to use. And there's another group of people who we call data scientists, or some people call them AI people, or, they apply algorithms to that data. And then there's another group, I usually call them people who do data visualization. Sometimes they're called analysts or people who do BI. And they take and try to explain the data in a visual or other means to the business customers. And then, as you said, there's sort of governance and security people. So you've got data engineering and data science and data visualization and data governance, who are all the main sort of components. And then the managers associated with that. And there's just lots of other roles that you could put in there. You could say a statistician is a form of a data scientist, or there's managers in there and scrum masters. But generally, there are these kind of four main buckets of roles that people have in organizations. Now, the question is, where do those four main buckets live in a company? And so there is a role that's actually really increased in number over the past 5 or 7 years, called a chief data officer or a chief analytic officer. And he or she is in charge of what some people call data offense and data defense, trying to actually get value out of data in an organization, or make sure that the data that's in an organization doesn't hurt it. And so I think in some organizations, the data engineers and scientists and viz and governance all work for that person, and he or she, is in charge of the data and accessing the data and putting it into systems that deliver value. And that's sometimes the case, right? They all work for one person, but it's actually not quite the case, because sometimes these roles end up in different parts of the company. So sometimes you'll have the data engineers and the data sources that they get from, like, people, the CRM systems or ERP systems where the data comes from. They live in broadly under the information technology. And that is generally headed up by a person called the CIO, or Chief Information Officer. And then sometimes the people who are actually trying to take that data and deliver value out of it for the business, sometimes they don't even live in IT. They live in what's called the line of business. And maybe they work for a marketing team or a sales team or a CFO. And so they're not on the same team. And sometimes your data science team is so new, they may not fit anywhere. Maybe they work for the CEO. And so the different groups and the different roles, if you imagine that there's these four main groups, they sometimes have affinity, like data sometimes is closer to IT and governance is sometimes closer to IT. Business is it's becoming more and more common with the aspect of self-service tools that the people who deliver visualizations from data or explanations on the data, they tend to be mapped more towards the business side, the line of business side. But it's, there's all counterexamples, right? There's complete line of business teams who do everything, all the sort of four major roles. And so it's kind of like you could take these four roles and take the way companies are organized and sort of pretty randomly distribute them, and you probably find somebody who's got the organizational model. But I do think over the next 10 years, more and more companies are saying, look, we want to be data-driven. We want to get insight out of data. It's probably better to have the whole factory and value chain of data under one person. And then that person is in charge of making sure that we're getting value out of our data and that the team is set. And so I talk to, there's teams of 40, 50, 400 people who are all 500, 1,000 people who are all trying to get value out of data. But that may not always be the case.
And one of the things that seems to contribute to this variety in where the different roles and responsibilities might sit and their reporting hierarchies is that a lot of the types of work that's being done provide value at different areas of the business, but there's also still a lot of unknowns throughout the business as to what the capabilities and what the needs are of those different roles and the best way to structure them, because they're such new positions. So data science, there have been statisticians for ages, but the newer capabilities with things like deep learning and machine learning are viewed as sort of magical solutions to everything. And so maybe the CEO wants to have a direct report who's able to answer all of their questions without necessarily fully comprehending the dependency chain behind them. And I'm wondering what you see as being some of the common points of confusion or lack of understanding to how the different stages of data play out and how that contributes to some of these elements of complexity and how it manifests within the organization.
Yeah, there's a couple of answers to that, right? So, for all of the listeners to this podcast and you and I, we sort of have this strange gift that, and I don't know what percentage of the population, maybe 5 or 10%, who are these high abstractors who can look at data and can really who want to spend 4 hours or a day digging into it and then can express that in a way that understands. But, a lot of people, they don't have patience, or they're just not interested or talented or whatever, their ability to kind of sift information, and they're looking for someone to do that work for them. And so they want to trust that person to give them an insight that makes business sense. And so your average business leader, they're getting more and more, and there's this term data literacy, but it's pretty rare that you've got someone who's the sort of top levels of companies who really spend a lot of time, pivoting around data, or know the differences between what kind of clustering algorithm or segmentation algorithm you use. And so, we have these teams of people who are trying to put this together. And so we've got these sort of strange skills that we can, abstract things in data, or abstract things in code, and get value on it. And so one aspect of that is that since we're a small part of the population, we think, but I've come to learn that it's actually not true. We don't really know what the people want, what your business customers, what the bigger picture is, because it takes so much work and so much effort to sort of wrest insight out of data and wrestle the complicated infrastructure that we think we know what they want, but we actually don't know what they want. And so one of the biggest precautions that I think is that you just have to be humble and believe you don't really know what the heck you're doing. And the only way that you can do it is to get feedback from that 90% of humanity, put something in front of them in a file, a dashboard, something that may not be perfect, and say, what do you think? And then have them guide you onto where the next step of value is. And so that's the, one part is that, us in sort of the cult of abstraction who can do the work have to really be humble about our ability to know what our customers want. And just because we took a lot of calculus in college doesn't necessarily mean that we're smart. And so there's a lot of bigger pictures and individual business decision making that we become cognizant of. And then, the other sort of interesting factor on all this, and in addition to sort of iteration and agility, is the factor that the tools that people have we've created in the market have kind of grown into sort of, I would think, two buckets. And there's a set of tools where it actually makes it pretty easy to do stuff with data. And that's not only Excel, but there's a whole bunch of what analysts call self-service tools. And it's like Tableau and Looker, and you can pivot around and get insight from a good data set, and then sort of push it to production with a button. There's a whole set of data prep tools that allow you to, and those are ones like Alteryx or several like Trifacta, Paxata, where you can do a lot of data work from a nice visual UI and has some algorithms behind it. And it's sort of, data engineering for non-data engineers. And even there's a whole set of self-service data science tools out there that try to do what's called AutoML to try to help you do it. And then of course there's the more technical tools that are backed by, code or visual UIs, like your Informatica or your SAS or programming languages or SQL and all that. And so the class of tools, there's this new class of self-service tools that enable people to do a lot of work. And so, and then also there's a lot of consulting companies that have come along in this boom area to say. And so if I'm a business person, I'm like, I want to get some insight. Do I talk to my IT people? Do I hire some people to use some of these self-service tools? Do I go call up a consulting company and pay them? And so it's a complicated world, right? If you just put yourself in the shoes of, I'm a VP of something or other, and I hear this data thing's important, and I want to get some of it. And so I think that, makes a challenge also in terms of how organizations react to data.
Yeah, the introduction of self-service in particular, I think, contributes to some of this area of complexity, because there's a high drive to be able to get answers from something, but they don't necessarily want to have to understand all of the different stages that happened before they started asking questions of a particular data set. So they might not necessarily traverse the entire lineage of a set of data to understand what are all of the additional pieces of context that come along with it. And so then it pushes a lot more of the upfront responsibility of providing that information as a readily available piece of the overall data and the way that it's presented to the data engineers and the data analysts and everybody who is working to get the information to a point where those self-service tools can have access. And I'm wondering what your thoughts are on just some of the ways that that and other elements within a business contribute to the organizational complexity of the data responsibilities?
Well, so if we think of these roles, data engineers and scientists and people who do viz and governance as kind of four categories, right? And then I think that the work that they do could be expressed in pipelines or maybe meta pipelines. And all those tools themselves are sort of not just data pipelines, but data science pipelines and data visualization pipelines and data governance pipelines. And so those pipelines themselves, if you think of them, they have different tools that people use that make up those pipelines. So it may be Tableau and Trifacta and one, it may be Alation in another, it may be Python and SQL in a third. And so the sort of pipelines that are all over the organization, if you look at it from that metaphor, and they're all sort of processing chunks of what happens with the data. And so, like, if you take that model, pipeline's in the biggest term, right? That everything's a pipeline, even self-service tools and even governance is a pipeline. Then the process of getting value to your customers is kind of almost Lego-like connecting these pipelines together because in some cases, they're whole and complete. Like an IT team can centralize a data warehouse and own the Cognos reports on it. But in other cases, you'll have partially a data enablement team doing a data lake, and then you'll have another set of machine learning engineers with a feature development pipeline and a model. And then on top of that, for instance, that batch model, there'll be some visualizations done by a group, and then you'll have the poor data governance person trying to put all the things into Alation at the end. And so, these sets of pipelines are distributed across the organization. So if you think of that, simple model, like, okay, there's an org structure. So these teams themselves and their different roles work on pipelines, and these, that they each own pipelines. And one aspect is that the organizational structure of those pipelines is reflected. The organizational structure that the people work in is reflected in those pipelines. And so, what is that? What is that reminiscent of? Well, if you think of Conway's Law, right, the sort of 50s, 60s guy that said the structure of an organization is reflected in the structure of the technology it's built. And when I was a software developer, you would, if you said, oh, that code is built up because of Conway's Law, that was not a compliment, right? That was something that was bad because you built the interfaces in your code not representing the optimal way that the code should be structured, but just because some VPs in a room divided up your group this way. And I think that's also true in the data and analytics pipeline world, that there are these pipelines and people control their pipelines. And you have to sort of connect these pipelines together to get business value to your customer. And so that makes a really weird perspective for your business customer, because first of all, most non-technical people don't understand the discontinuity between why is something easy and why is something hard? Why is changing a line chart to a bar chart can be done right in front of me, but actually adding a new data file takes 4 months? And that like drives them crazy. They don't understand the discontinuities. And I spent years trying to explain this to people, and they just, it's hard because you have to understand how the thing works to make it happen. And that's part of the reality is what level and what pipeline it goes into, the complexity goes up. So it's easier sometimes to think about, do things quicker. So if you imagine, like, let's take a scenario. I've got, a VP of sales, and they've got some dashboards, and then they've got some models behind those dashboards and some data, and then it's being accessed from some internal and external systems. So he asks you to do something, he or she asks you to do something. And let's say that's called a segmentation of their customers. So once that segmentation could be created from a data science model, and you could do a random forest on the data and get this sort of complicated series of if-then-elses and apply that to do the segmentation of your customer. Or maybe there's some other algorithm that you want to do, a k-means clustering. But you'll end up with something that's kind of like an if-then-else. Or maybe you just go into Tableau and create a segmentation if-then-else. Or maybe your data scientist creates an attribute of a dimension, or your data engineer, creates an attribute of a dimension in a Kimball-like fact table. Or maybe somebody on access to the data creates an if-then-else in Python. So like where that if-then-else lives is actually really relevant to what layer of the stack or what pipeline it lives in. It's a relevant discussion to the design, and sometimes things, and often to generalize things, it should be lower in the stack because that has more people upon it. But the cost of doing that is also plays out. So maybe it's just easier to do that if-then-else tweak and do it in Tableau, give it to the VP of marketing and say, say, what do you think? Does this make sense? And he or she could go yes or no, and maybe you solve the problem. But then, there are these data pipelines, but there are the logic or the code or configuration that happens in all these diverse pipelines. And so that in and of itself is an area that DataOps talks quite a bit about. So, organizations have different roles. Those different roles create pipelines. Those pipelines live in different areas of the organization. And then the design decision about where the interesting work happens, the if then else, the logic is I think sometimes not done. It can create challenges that are represented by the same challenges that Conway's law found.
Yeah, the communication between pipelines and between members of the organization is definitely something that can very easily get reflected in the ways that data propagates throughout, because you have somebody who asks for a particular piece of information and then you say, okay, well, I'm going to add it into this report, or I'm going to collect it as an additional field from this data source, and then it gets delivered to the next stage. And you need to have some interface by which you can say, okay, this pipeline is complete. Here's the handoff to the next stage, whether it's from data engineering, collecting all the data, loading it into an S3 data lake or into a data warehouse, and then handing it off to data scientists to run their analysis. And then another element too is that a lot of the work being done in these pipelines is optimized for moving forward, but then it can be difficult to have useful bits of information propagate back to form feedback cycles to determine, is this pipeline working effectively? Is it providing all the information that's necessary? And then by the time it goes from the source data through maybe 5 different levels of pipelines to the business end user, maybe the CEO, who then says, okay, well, I've got another question, or this doesn't quite answer the question that I had. You've already spent a lot of your lead time getting everything to that point, and so you don't necessarily have the time to be able to go all the way back to the start, optimize all the pipelines, and get the same answer back out again. And I'm wondering what your thoughts are on some of the useful ways to create those feedback cycles and shorten that iteration, and some of the useful interfaces for designing those communication patterns, both from a technical and an organizational perspective.
Yeah, that's an important question, right? Because if you think of this case where there's, everything sort of a pipeline as a metaphor, right? And there's data engineering and data science pipelines and data visualization pipelines. And there's, if you're trying to do something good for your CEO, right? And it's the CEO, let's engineer it right. Let's put that at the lowest level in the stack so everyone can use from it. And that's probably a good idea, right? From a technical standpoint, but is it actually valuable, right? And you don't know if the CEO likes it or not. He or she may want to tweak it and tweak it again and tweak it again until it is right. And so putting it at the lowest level of the stack and taking months to get it out could be exactly the wrong thing. And so it is really unknown about how much work it takes to actually say that you should do something at enterprise scale or at the lowest level of the stack. And this may be heresy to people who believe in enterprise architecture, but I think it's better for things to try to have, if you're going to invest in things from the center out, it should earn its way down instead of abstractly being able to get it there from the beginning. And so if you're going to do an if then else, do it in as quick as possible in the data prep layer or the data visualization layer and see if it's right. And then when it earns the right to be useful, then have it go back down farther on. Into the lowest level because of that fan out problem, because of the centralization versus freedom problem. And so the other part is that the org structure may not permit that. You may actually not be able to sit and say, okay, CEO wants X. Where are we going to put the if then else? Is it going to be in Tableau, or am I going to model it, or the data engineer is going to do it? Then you may not be able to have that conversation, right? Because no one owns the relationship, right? And so there's there may not be a CDO who can kind of sit and say, okay, we're going to do it. I know what the CEO wants, so we're going to do it. This is really important. We're going to do it at the lowest level. Or we're just going to get it quick the next day. Could you just flip it up in Tableau? And so these design discussions end up almost being territory level ones. And I've been in discussions where very mature people I respect, data architects, say, I only do enterprise architecture features, and they weren't interested in anything that didn't have that sort of more fundamental one. And, I can see their point. And then I've sat in rooms with people who, are really, really good at Tableau and think that those enterprise people are complete idiots and that they're really focused on trying to iterate things. But then, they end up wondering, well, why do we have 3 definitions of market basket across the company or 8 definitions of the same term? And so everyone's wrong and everyone's right in this equation. And so it is really a very fundamental thing that happens in analytics about this relationship between the centralization function and the distribution and how those pipelines are managed. And then fundamentally, like, how do you collaborate? Right? How do you connect all these things together to make it right? And so there is one way that says you should have a lot of meetings and have a lot of documentation. And when things go wrong, when that CEO gets the if then else, and then 2 weeks later it breaks and starts yelling at people tend to write Word documents and emails and start to have technology review boards and formal paperwork and spreadsheets that you've got to have checklists and so that things don't go wrong. And that's not unreasonable, right? No one likes to get yelled at by their customer when things go wrong. And data is a business where things will always go wrong because it's a factory-like system. And so that's one way. You just start having more meetings. And then once you get more senior or you become one of the people who are smart, you get pulled into more and more meetings because you've got more and more of the picture of the whole system in your head. And pretty soon, like half or 9/10 of your time and you're the most valuable person in the company is spent in meetings, like reviewing code and making sure everything's right. And then you get frustrated and you're like, oh, this sucks. I'm going to go get a new job. And that most talented person walks out the door. And that's just not a great situation because then no one's got the whole pipeline organizational data map in their head anymore. And so I think that is a very common circumstance because of this centralization versus freedom, self-service versus home office, IT type world. And it also gets further complicated because another person in this world is the operations team, the people, because you're creating, if you talk about where that if then else goes and which one of your pipelines, every one of those pipelines has a development stage and a production stage. And so when you take something and put it into production, then there's different paths, right? In Tableau, I can click a button, it's live. Many organizations have a dev and a QA and a UAT and a production environment, and it can take them 3 to 6 months to take 20 lines of SQL and get it from one stage to the other. And so it's not only the organizational complexity of the people who are creating it and where they live in the organization, but also the production team who runs it. And so it's almost so much nicer in software where you've got this nice one-to-one relationship between dev and ops. It's so nice. I've got my ops team, I've got my development team. We've got a front-end group and a back-end group. Oh yeah, maybe there's a nice, well-defined GraphQL interface between them, but that's fantastic. But like you've got this many-to-many relationship because there's not just one ops team in this. There's sometimes multiple ops teams because there's a central one and there's line of business ops and then there's development team running their own ops. And so that becomes another challenge as well because basically one of the main common threads across anyone who does data science and engineering and visualization is they want to do new cool stuff. They don't want to be fixing data problems on Saturday. Like they want someone else to run the operations or they want to run it hands off.
Yeah, I could definitely sympathize with the not wanting to solve those problems on Saturday as somebody who does work in operations. And I think your point too about the relative simplicity of the software development lifecycle of you write your code, you put it through your CI pipeline, and then at some point it makes it out into your QA environment, eventually to production. And I'm wondering what your thoughts are on the relationship between the current trend towards trying to break some of these different software applications down into microservices to simplify and reflect some of the organizational communication patterns and the viability of a similar approach in the data and analytics space, given the multivariate layering of complexities of the different pipelines, both in terms of the code and the data and the organizational requirements on top of that.
Yeah, it's interesting because if you look at the microservice model, right, sort of monoliths versus microservices have the sort of quote two pizza team that does everything all the way down from UI all the way down to database schema, right? And you can kind of componentize them together. And that's a great model, right? They're sort of vertically integrated teams that can run. And then you've got the lateral communication challenges when you've got a bunch of microservices running. And so, both have their mix of architectures, right? The monolith that's back end sort of, where it's back end, front end DevOps group, and that works. But then you've another where you divide it up into services. And I think in the data and analytics world, it's a little bit different because it's as if you had teams some teams, part of the application was done with a front end combined, where some of the teams use low code tools, are doing both back end and front end work. Some of the teams are doing low code tools, doing front end work. There's some people who are doing high code tools with IDEs who are doing back end work, and they're all working on this big application, and some of them don't even know the others exist. And so there's not a sense that they're in the same shared business together, because there are literally, in most organizations, 30, 50% of the people do something with data and analytics. Maybe they're a consumer, or, in more and more organizations, they're trying to actually take and get insight from data themselves. And they may be in all sorts of different organizations where they do an export and get data and integrate with another data set. And so we're all a part of, so in some ways I see data and analytics ahead of software engineering and the organizational complexity, or maybe behind, I don't know, because, certainly software is going to get to, there's been a lot of low code tools like Mendex out there. There's been a lot of sort of SaaS products where you can do sort of partial integration tools. And so we're getting into a world where software itself is diversified, and the value chain that someone gets in an app could come from a low code tool and a SaaS app and an enterprise app, all sort of woven together. And you've got to be able to do kind of CI and CD on that. You've got to be able to deploy it. I think that same structure is has already happened, and is completely out of the gate in the data and analytics world. This is the world. There's just so many different groups doing different pipelines in different organizations. And if you want to have a hope, like my company is trying to get people to be able to deploy quickly and to be able to deploy with low risk and safe. Most organizations now, they'll have a data warehouse team, and they'll have no idea, if they change the name of an existing column, what the damage is going to be. The only way that they can find that out is by going out and sending email and talking to people. And that's just, to me, that is a suboptimal way of handling collaboration. Because I've been a technical guy now for freaking 30 years, and I know my technical people. We don't like meetings, and we don't want to coordinate with other people. We want a button that says, if I change this, did other shit break? That's the button I want. And everyone wants that. And so you need to empower people to have that button saying, okay, if I change the title or if I change a column's name, what's the effect of all my other pipelines that are my data science pipelines, my data visualization pipelines, my data governance? What's the effect of that? And when you've got all these pipelines floating all over the organization with no coherence to them, you have no idea. And you have no idea of any sort of effect. And what frustrates me is people seem to think, that's all right. That's the way the world is. We just live with errors, and then we're reacting on Friday. And then you wonder why there's so many people who have gone in with high hopes from getting their data science master's degree and come out really frustrated, or why the number of data and analytic projects fail over 50%, and why the number of companies who are data-driven reporting data-driven are actually going down. And so there's a lot of reasons, but it's not because we don't have cool tools. It's not because we can't run a database query faster or build some ETL code faster. That's not the reason. The real reason is because of these people and process and organizational challenges. And if we don't face up to that and take that as a primary thing in our work, then I think we're going to be in a world of hurt. And I think that's what happened in software, right? We were, it was the dev and ops world where the developers were throwing code to the poor operators who we thought were lesser beings, back in the 90s. And when I was a software engineering manager, we threw code over the fence and we'd walk away. And those people who did ops were paid less than the cool Java developers. And, 20 years forward now, DevOps engineers make more than software engineers. And that's the way it should be, right? Because they're actually handling a big hunk of complexity. Or maybe it shouldn't be, I don't know. But at least they should be parity. And that relationship between dev and ops is fundamental. And so the relationship between all these pipelines writers in the organization and their operations is fundamental. The many-to-many relationship is fundamental in how data and analytic teams work. And if we don't solve that, we're just going to be continuing the process of sort of techno-fetishism, where we believe the next algorithm or the next tool is going to actually make things work. And that's something I'm just entirely sick of. I'm just really sick of the belief that if I buy another tool, this all will happen and I'm also sort of sick of the BS of vendors that they go. And I go to conferences and see it all the time. And so there's a set of things that we're not focused on. And organizational complexity is one of them, and operational, the way at which we push things to production, and the operationalization of models and data engineering is also another one. And so those things, I think, are really, to me, the surface of attack that we've got to focus on. And, I'm trying to talk about these things and give a perspective on them, because just having been around it, I've seen it so many times. And it really is sort of a mindset change that people have to go through to sort of think of, because normally you grow up as a technical person, you're like, oh, organizational stuff. Oh, roll your eyes. That's for like managers. I don't have to deal with it. But, I think the DevOps idea in software was that there was an organizational barrier that needed to be broke down. And I think the organizational barrier that needs to be broke down in data and analytics is not just Dev and Ops. It's the multi-pipeline all over the place, multiple tools, centralization versus freedom versus production problem. And it's that many-to-many problem that we've got to solve. And then, the secondary, or maybe or at the same level, sort of deployment and CI/CD and testing and environment management problems.
And another element of the multiple different pipelines that all of these different teams build is that a lot of the time they'll end up duplicating efforts, and sometimes with different contexts or different concepts of what it is that they're trying to solve for. And then you're left trying to reconcile why there are so many different ways at getting at the same answer. And so we've tried to solve this through things like master data management. And then there are tools like Superglue from Intuit for being able to see what are all the different steps that go into a given report. So you can say, okay, this report has this value, or this report didn't update. What are the different stages that happened before it, so that I can go back through to try and debug the problem? And so there are some approaches to it from a technical perspective and tooling perspective to address the issue of surfacing the sort of canonical set of data or the canonical way of doing things, or saying, I've already done this, you don't need to do it again. So things like data discovery with Amundsen tool or other things. And I'm wondering what your thoughts are in terms of the design problems in the tools and the technical systems that we use that contribute to some of these organizational and operational challenges of duplicated effort or lack of the visibility in terms of the data that is available across the organization.
I believe that the center of problem relies in the processing of the data and not the data itself. And so the processing of the data is a code and configuration driven system. And so in every one of these pipelines, there is code and configuration that is running. And maybe that code runs in a Java VM. Or it runs in a Hadoop cluster, or in a database, or in some ETL engine, or some visualization tool, or it just runs in Python. But it's all code, and that to me is the perspective that we need to focus on sharing and reusing and centralizing and distributing and all that stuff. First of all, it needs to be in Git, and it needs to be versioned. And so I need to know what versions of my code went into producing this stuff so I can understand it. And then the second part is like, how do you promote reuse and sharing in a system and in a big analytics system where you've got these pipelines all over the organization? Well, first of all, the commonplace now is not that all these pipelines are centralized, and they're not all in Git. Some of them are in share files, or somebody's using Git, or like there are all these sort of rat trap tools out there that say you store it in my system and I'm going to have my own Git, and then he's going to have his, and she's going to have their own Git. And so there's no there. There's no place to like know where your process lives. And it just, that number one seems just entirely insane to me, because you're a data-driven organization. The IP of your being data-driven is the processing of the data. It's not the data itself. As an example, why do hedge funds have that stuff under lock and key? Because the processing of the data is their value. And so we need to centralize that and put it in Git or multiple Git repositories, but just get it somewhere where people can. And then the second part is, how do you actually create reusable components and get people to refactor their code? And well, first of all, is recognizing that it's code. And then, what happens in a lot of organizations is code is mailed. I mail a SQL script or some Python script, or here's a Tableau workbook. And then, or I pick up one from a shared drive and then I rename it. And then I start editing from there. And so what happens is, if we just think of the world as a bunch of if then else's in a simple way, and if then else is in one Tableau workbook, now it's sort of spreading and like a virus to a bunch of other notebooks. And well, do you know where that if then else is? How many notebooks is it in? Is it right? Did someone change it? And maybe that if then else is one of the things that the CEO looks at. So you need to refactor and think of the work that you do in data and analytics like software, and you're in the complexity business. And so you have to think about how you can make time in every unit of work that you're doing, if you call it a sprint or call it a project, to improve what you've already done, and refactoring and making libraries and handling. It's not organizational complexity, it's code complexity, that and not how to have these big hairballs. And so libraries, refactoring, reusable components, shareable components all need to be in the discussion here when you're building these complicated value chains of that happen to have data flowing through them to get value. So, because I think a lot of people have the mistaken notion that, and I don't know if it's mistaken, but they give too much weight to data, and they think somehow data is different, and, oh, it's the data is big, or, oh, the data is complicated. And so it doesn't matter if the data is big or small. It doesn't matter if the data is structured or unstructured. It doesn't, matter if it's pictures or nice rows and columns. You still have these systems at which data is that's being acted upon, that are guided by code. And that's what we need to focus on more so than worrying about data. And, I find that none of these systems are ever going to, that one you mentioned by Cisco of like, I can do trace precedence across my report of where all the lineage came from. In most organizations, that's just a complete pipe dream. It's going to happen because you've got 4 different languages acting upon it. It's gone through 4 different systems. And so you have like, at least you could have a chance of it if you had all your code in one place that acted upon it, and you knew to produce this data, here's the codes that acted and here's the results that it came from. You could have a chance, but sort of the data-centric view, I think it's just mistaken, because we're trying to look for that. We live in a best-of-breed distributed systems world, and data systems are one of the more complicated distributed systems out there, because they go through so many places and so many transformations, and they hop from system to system. And I think we've got to recognize that this is sort of a distributed system type problem, and that it's getting worse with the cloud and with the idea that you can have these ephemeral infrastructures that you can turn stuff on and off. And so we've got a distributed system problem here. And so having the sort of Grand Inquisitor boot on the neck, here's the one system that's going to rule them all. I think I just mixed metaphors there of Lord of the Rings and the Princess Karamazov. Sorry about that. But that sort of thing's not going to happen. And, people want to try it with very smart, very creative, very interesting people in data and analytics. And there's all these new cool tools that are coming upon. But the common denominator across every one of these cool new tools is they all take code and configuration to drive them. And that's where people need to focus their time and start talking about which is the right tool from the job, what place is it, how can I make reusable components that I can share and understand, and then how can I see the effect of a change in one of those pieces of components in the larger system, because it's a network that we're talking about of these pipelines. And so how do I, if I change the if then else, which I happen to write in Scala, which actually ends up changing the schema, which means the data is going to be different, which means a model is going to be affected, and for reports, you need to know that ahead of time. It's absurd that you have to have meetings to do that, or you're just hoping, you're waiting for your customers to find the problem. And so how like un-DevOpsy and un-agile is that? I mean, I think it sounds fun, but it's not the sort of passivity of data engineers and data people sort of waiting for things to break. It's really, I find, very frustrating, because there is a better way that you just don't have to sort of take the abuse of like, oh, I didn't know it's working and suddenly it's wrong because I can't conceive another way of living that I'm, and, if anything, that gets me up in the morning. And again, I'm on sort of, I must be working from home too much, but that the data engineers and scientists and people who do data visualization need to sort of reclaim control of their destiny. They can't live in this passivity of like, I only focus on my little thing and that's done, and I don't know what happens in production. I don't know if people are using it. I don't know if it breaks. And oh yeah, I'm going to get calls on Saturday to go fix stuff, and that's just my lot in life. And I think that is an entirely too passive way of working, and we all as an industry need to sort of reclaim control and sort of stop the techno fetishism and stop the sort of way of thinking that data is different, and we're a complexity organization, that we have to deal with the complexity and the code as front and center things.
What are your thoughts on things such as Great Expectations or other means of creating these dynamic assertions on the data as it traverses systems as a means for being able to regain that control and visibility throughout the organization?
Oh yeah, which I freaking yeah, great expectations is great. I love automated testing in production is like hugely important, right? Because so first of all, you run a factory, right? And those factories consist of bunches of pipelines that are been placed on that factory by different organizational structures. And at the end of the factory is your customer. And so the input to that factory is raw data, and each one of those pipelines are processing it, based on the entirely arbitrary organizational structure that people happen to have. And so they reflect Conway's law. So how do you know that pipeline worked or the raw material going into that pipeline is actually right? And so you need to do these, whether you do assertions or you just have tests, then there's a whole nomenclature of sort of running on top of production. Software people call it observability or monitoring, or some people call it testing, but it's on production to make sure that when a data item goes into the very base level pipelines, and as it follows its way through the system of pipelines that the organization has decided is there, that when you end up with something at the end, that it's right, that you're not going to be woken up on Saturday morning or pulled out of the soccer match, or like one of the guy I met at a conference saying he was his kid's birthday party and he was sitting on the bathtub fixing some pipeline code on that Saturday because something was wrong. And so there's just got to be a better way. And testing in production gives you a way to help ensure that you don't have those problems because you're alerted sooner. And then the other sort of opposite direction of testing is the sort of more software-like testing where you're doing regression and functional and unit testing that happens not on production with production data, but happens in development on development data. And I think that has a whole level of testing too. But I think the great win here is that the intersection of those sets, those sort of production, observability, monitoring tests that happen when your data is changing but your code is fixed. But in development, your data is fixed but your code varies. And those two sets of tests, automated tests, and however you group them together, are largely the Venn diagram that largely are the same. And you should always spend 20% of your time doing automated testing. And if you're not, you're just in a world of hurt. And it's, we're building these high code systems and the test to code ratio is so low. And if you're any kind of software manager, you just like pull your hair out when you see these. And so that's also the way, because I jumped ship from software development in 2005, but, having been companies that I've been part of the software because the companies I've worked for have built software. So, I think great expectations. There's other companies that are just starting to focus on observability and production monitoring, but testing, it's sort of the duality of testing, monitoring and in production, and then doing what we would consider software developers do in development. That's super essential. And you won't get any of the benefits without it. And it has to be across every pipeline in the organization, right? Because you want to, how else are you going to tell if, okay, the organization's got pipelines all over the place. And let's say you have some software that spans all those pipelines across the organization. And, my company has happened to build one of those, or you could build one yourself. And I change something in the back end of those pipelines and my data warehouse. And now I can suddenly see that I've broken my Tableau reports. That's fantastic. But the only way you can tell if you've broken your Tableau reports, because those, of course, are built in a different system with a different engine that they run in, is to have automated tests on top. And so you need tests across every bit of technology to make sure that this system works. Because you need a button to push. If you want the button to push that says, if I change this, will things screw up? And you need that button to happen on every pipeline. And so across all the organizational structures that people have. And so that's what really is it's not about meetings and it's not about let's hold hands and have really good Jira ticket tracking. And that's the same idea that came in CI/CD. It's like, if I can push things to production, if I can do continuous delivery, if I can have my 22-year-old who just got to college make a change in my million-line web app, and they can actually deploy to production because they're empowered, that's fantastic. And how many data organizations actually benchmark themselves saying, I have a 22-year-old data engineer, I'm giving them a button to say push to production? I mean, does anyone who even listens to your show have that case now and know that it's going to work because they've been able to test that they haven't broken any models or visualizations or governance on top of it? That's a fairly rare company, and I think that's one of the things that I think we should change.
And anybody who does have that magical button, please let me know so that we can have you on the show.
But I don't think it's magical. I actually, I just think I think it's necessary, and I think it's a change in perception, because we have to build a system next to the system that we're building that does that work, and that is actually work that the smarter people in the organization should do. Satya Nadella's got this quote, this great manager of or leader of Microsoft he really turned it around. He says if a developer, and this means software, has to choose between a feature and productivity, they should choose developer productivity. Tesla talks about it's not about the machine, it's about the machine that makes the machine, the factory. I mean, how many people, Google's got thousands of people who work on productivity. And so even Deming said, when there's a problem, it's very rarely the special cause, a person being lazy. It's often the process that the team lives in. And so we've relegated the process that these data and analytic teams live into a human realm. And I'm saying you need to build systems to instantiate that process. And that is part of your job. And that is actually a productivity enhancing thing. And as a CDO, that's often one of the most important things that you can do. And so you should have your smarter people working on that infrastructure for productivity, that infrastructure for low errors, that infrastructure for collaboration. And that's going to pay untold dividends. And that's why DevOps engineers are paid more. That's why any software project now that doesn't have a CI and CD pipeline, that doesn't have automated monitoring and observability in production. You shouldn't, there's Joel's list, right? That says when you go, like Joel on software wrote this list and is your stuff in source code? Can you have a build? Your developer box shouldn't take 3 weeks to get set up. We need a list like that, and people have to have, it's a different perception of what's value, and we've got to get rid of my value comes from the fact that I've tweaked my UI or model. It comes from we're building systems that people need to work in, and it's really important that the systems that people need to be working be well engineered. And so and whether those well engineered operational systems that people work in, I have called those DataOps. And there's a bunch of stuff in there and a bunch of companies who are focused on that. And some people call it ML ops or model ops. Some people call it observability for data science. Some people say it's CI and CD for data engineering. The terms are all out there, but it's sort of a mental focus that really changed in software engineers. And it really changed for me kind of in the 2000s, where I thought release engineering and operations were really for lesser beings. And I really, that changed, and the relevance and the importance really rose up. And that's what I think the DataOps idea is about. And that's, I think, why a lot of people are interested in it, because they see that it's just, it's not about, it's a different perspective on the world. And we need to build really strong, really well-engineered systems that allow us to do good data engineering and science and visualization. And so that sort of systems approach and engineering approach to putting together these complex distributed systems across an organization and across the diversity of people and the diversity of data, I think is really important.
And one of the core elements of DevOps in particular that you've touched on a few times is maintaining the focus on the business value that you're producing and not just on the technical widgets that you happen to be churning out. And that's a big point of the complexity that's arising in these data organizations as well, is that it's very easy to get deep in the weeds of tuning the distributed system for performance or making sure that your pipeline is reliable and has high uptime. But if all you're doing is delivering bits that nobody actually looks at, then you're just wasting your time. And so what have you found to be some of the most useful strategies for being able to maintain a connection to that business value and the business need throughout the different stages of the data lifecycle, and being able to propagate that information throughout the entire organization and the data responsibilities that are touching on all those different pipelines?
Well, I'm a believer in being data driven. And so I think the pipelines across an organization and the people who are building those pipelines and the people who are operating those pipelines, they need to be measured. And you need reports and algorithms and data flow off those systems to be able to understand if they're working. And that is a way that you can judge whether your system as a whole is effective. And part of those reports could be a net promoter score of your reports. They could be a view score of who's looking at it, but they also could be as simple as, what's your test coverage? Do you have tests across all your system? What's your deploy rate? How are you judging the productivity of your team? How many feature points are they getting in? What's their rate change of things on a particular project? You can also look at, are they being on time? Are they meeting their SLA? And then one that's hugely important, I think, is error rate. If you look at the sort of lean manufacturing Toyota idea of sort of loving your errors, counting your errors, and then putting together plans to remediate those errors and saying, okay, well, we made an error, let's fix it. And so it doesn't happen again. And getting away from a shame and blame culture to a more error loving, maybe you call it lean or total quality management. There's lots of different terms on it. And so I think if you're going to be able to have an effect on the customer, you need to iterate quickly because you don't know what the customer wants. But in order to iterate quickly, you've got to build a system that observes how your team is working. And you've got to measure what your team is working. And I find it somewhat hypocritical that the people who lead data and analytics organizations don't run their own data and analytics organizations with any data and analytics. That they're like, where's the report that tells that my team's doing? And so I wouldn't hire a software engineering manager who couldn't describe to me what's in his or her one-page dashboard for running a software engineering team. That's expected, right? And so what's the kind of report that a CDO has to prove that it's there? And I find that those sort of operational metrics, I think, are really important for not only for teams to prove their worth in data and analytics, the boss's awesome report for the CDO, but also for a way for people to overcome some of these organizational problems. Because if you're a data person and you see data, you're going to react to it and say, okay, it becomes, instead of being Hatfields and McCoys, you're wrong, we should do it here. It's like, here's the data. Look, we've had 10 errors and here's the source of the errors. What's the number one error that we can fix? Is it the error because a data quality problem in our source system? Was some action that happened upon the data wrong? Did our server go down? Was it just late? What's the error and how can we remediate that error? And so reflecting and using a data set and having a shared experience of what's happening with the process of our data instead of anecdotes and side comments, I think is important. And as a data person, you should believe in data. So why aren't we getting data about what's happening with our data? And I think that can also be very helpful for people in overcoming these organizational complexities and as well as these technical complexities, because you can start to see and understand what's happening and be able to then have a sort of a shared common experience. And then that shared common experience can be used as a basis to overcome, people's natural reluctance to admit that there's something screwed up and that they screwed up and that they have to improve.
Are there any other aspects of organizational complexity or technical complexity in data organizations that we didn't discuss yet that you'd like to cover before we close out the show, or any last pieces of advice for people particularly working in the data engineering space?
No, I thank you for the opportunity. It's been fun, and hopefully I didn't. I feel like I was talking too much, Tobias, and I didn't give you a chance to ask the questions. But I sort of got going today. But yeah, I think there's a real opportunity for us to reframe how we work together, and if we focus on building that machine that makes the machine, I think that's a really interesting challenge. And I think if anything, that's what's happening in the world now with COVID-19 and the upcoming recession. We're going to all have to face the challenge of how to do more with less, because we're not going to get speculative projects anymore. And so my fear in data and analytics is that we've gone through a boom cycle and that we're going to go through a bust cycle because people aren't going to see the value in analytics. And the only way I see to fix that bust cycle is to focus on operational efficiency. We can't invent another two-letter algorithm, right? It's been ML and AI, and big data is a word, and the industry sort of invents the next buzzword, but we've really got to focus on effectiveness, doing more with less, because we're in a recession and we're going to be in one for a while. And the data and analytics field is more and more teams are going to say, we got 50, 100 people doing data and analytics. What's the value? You mean I can only update my data warehouse every 3 months? And we still got some consulting teams doing this. And or we've got contracts with people and they're paying them $10 million a year to give us reports. And so, the yield of our data, if you look at it as a whole, the yield of our data and analytics investment, we're going to have to focus on in the next 5 years, because that's just what happens in recessionary cycles. And I think that's actually a good thing. And it's really an opportunity for people to reframe how they think of it and saying, okay, yeah, I've done machine learning, I've done some algorithms, I've done some data science, I've done some viz. well, what's next? Well, the next thing is focus on the effectiveness of the system, which is applying these sort of data ops type principles to it.
Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Well, I think there's actually in my area, the data ops area, and maybe it's self-interest in saying this, but I actually see there's more smaller companies working on individual pieces of the data ops equation. And so whether it's on deployment or production monitoring or data privacy, test data management, I think there's a wealth of opportunities because that sort of operational area of it's not about databases or ETL tools or Viz tools or data science tools. It's how you operate that whole system with complicated data in a complicated organization. There's a lot of runway there for people to do. And if you look at the amount of innovation that's happened in the greater DevOps market in software over the last 10 years, and between open source projects and closed source projects and consulting companies, there's just a lot of runway there, I see. And because there's just a lot of things that you can do and ways that you can approach from growing your career, from learning technology. So to me, I just think there's, we have a DataOps blog. We've written about the DataOps enterprise software industry. There's a bunch of companies there, closed source, open source, different ideas. And I think it's going to be a really cool next 5 years to see the industry emerge. Like I just talked to a company this morning who does what they call data SecOps, which is really applying security principles to the data that's being transformed in a data ops driven process. And so there's a lot of I think cool stuff going on that give people a chance to learn and for people a chance to get involved in.
Well, thank you very much for taking the time today to join me and share your experiences and thoughts on the ways that data ops can help improve the organizational and operational aspects of the data pipelines that we're building and running. It's definitely an interesting area and a challenging one. And as you mentioned, one that we need to spend a lot more of our focus on. So I appreciate all of your time and efforts on that front. And I hope you enjoy the rest of your day.
All right. Thank you much, Tobias. Have a great day.
You as well. Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.